Okay, today we're going to do an integral that is involving trig substitution. Okay, so here we have the integral of x to the third over the square root of x squared plus 121 dx. And we can identify that this is going to be an integral involving trigonometric substitution because we have a square root of something squared plus or minus something else that can be squared. Okay, so it's going to be a square root of a binomial. All right, one of the terms will contain x's, the other term will not contain x's. And you cannot solve this problem using simple substitution, because using simple substitution you will let u be the inside here. So then you can get a u to the negative 1/2, which is an easy integral to do. But if you notice du, the derivative of the inside here is just 2x. We need x to the third. That's not going to cover this. So that doesn't work. So this leads us to a trig substitution. So the first idea here, the first concept we're going to work on with a trig substitution is how is the triangle, nice triangle, how is this triangle going to set up? Okay, well, when you have square root of x squared plus 121, we know that if this side is a, this side is b, and this side is c, we know that c squared is equal to a squared plus b squared. We also know that c, therefore, is equal to the square root of a squared plus b squared. Okay, now any of the legs, be it a or b, would equal the square root of c squared minus a or b squared, depending on which one you're solving for. So if you notice here, the hypotenuse is always the square root of the sum. One of the legs is always the square root of the difference. Okay, so when we go back to this problem, if you notice, this one's a sum, so this here is the hypotenuse. Okay, this is the hypotenuse. So now we're going to erase this actually. No, we're not going to erase it. We're going to draw a new triangle for this problem. Okay, here's theta. And we know that this is the hypotenuse because it looks like this. So this is the square root of x squared plus 121. Okay, which means the legs, which in this case are going to be u and a. We always make the legs u and a, where u is the one that contains the variable. U squared is x squared, so u is x. A squared is 121, so a is 11. Why are we taking square roots? Well, because they're squares here. Okay, this would be x squared plus 121. We're looking right here. This would be x squared plus 121 here. So then each of these would be the square roots. It would be x squared plus 11 squared. Okay. All right, so u is x and a is 11. So now what we learned in class is that the constant, if you were given the a, the constant always is the adjacent side. And the u is always the opposite side. Do it that way. No matter where the square root ends up, the u, unless the u actually is the hypotenuse, it's always the opposite side. And a, unless a is the hypotenuse, will always be the adjacent side. Okay, now we can use our SOHCAHTOA, our trig ratios, to come up to find out what x is and to what the square root is, so we can plug them into the original equation. Okay, so what is x? Well, we know that we want to find out what x is, but not in terms of the square root, because the square root has x's in it too. Okay, we want to know what x is just in terms of 11 and theta, because there's no x's here. And then we can find out what x is. Well, if we're using theta and 11 with this x, well, what are we dealing with here? Okay, we're dealing with this length, this side, and this side. This is the opposite side and the adjacent side, so this is tangent. Okay, so since tangent of the angle is equal to the opposite side over the adjacent side, we know in this problem that tangent of theta is equal to x over 11. Or, what we really want to know is if we've multiplied this by 11, we really want to know that x is actually equal to 11 tangent of theta. Okay. All right, now we want the whole square root because we want to replace we have x cubed, so now we're going to put this in for x. We got that replaced. Now we need to replace the whole square root. Well, what's the square root? Well, don't use the x. Use the 11 and theta. Well, this is dealing with the hypotenuse and the adjacent side. Now, some people would think, well, if we're dealing with hypotenuse and the adjacent side, we're going to deal with cosine. The problem is that with cosine, this part is going to be on the bottom. Okay, because it's adjacent over hypotenuse. But we want this on the top, so we can just move the 11 over. So what we really want is we want secant. Secant of the angle is equal to the hypotenuse over the adjacent side, which in this case is the square root of x squared plus 121 over 11. And this is equal to secant theta. Or, if we move 11 over, the square root of x squared plus 121 is equal to 11 secant theta. Now, these are the two main things we're going to be using, this one and this one, because these are going to go into our original problem, which is up here. Now, we need one more thing. We can deal with x to the third. I'm up here in the original problem. We can deal with x to the third because that's just cubing this, not a problem. We've got the square root on the bottom. That's just 11 secant theta. We don't know dx. So we have to find dx. Now, all dx is, of course, is just the derivative of 11 tangent theta. Okay, what is the derivative of 11 tangent theta? Well, it's 11, not that. It's 11. The derivative of tangent is secant squared, so it's that. So we're going to use this too. Okay, now we're going to draw our integral. So we have all the things we need to replace this. So all we're doing is just replacing in here these. Okay, so what we have now is we have the integral of x to the third. Well, x to the third is going to be 11 tangent to the of theta cubed. Okay, so what is 11 cubed? Bring up my handy dandy calculator here. 11 cubed is 1,331. Okay, we need that. So this is 1,331. That was 1,331, right? Yeah, okay. 1,331 tangent cubed theta. Okay. Over the square root, which is just 11 secant theta. So just copy it down here. 11 secant theta. Times dx. dx is 11 secant squared theta. And then the d theta. And now look, I claim because of how this triangle is set up, this here is equivalent to the original problem. Okay? All right, so now what we're going to do is now we're going to solve this integral. So I'm going to leave that up. Okay, so if you look in this integral now, well, look at what we can cancel. We can cancel an 11. Okay, ooh, I'll use red. We can cancel an 11. We can cancel this secant theta with one of these, so there's one left, and I think that's it. And I'm going to remove that 1331 outside. Okay, so what we have is we have 1331 integral of tangent cubed theta secant theta d theta. Okay. Now we have a section 2 problem. This is now from section 8.2. And this isn't too bad because remember the basic rules are secant, even, tangent, odd. Hey, tangent's odd. So what we're going to do is we're going to save here, is we're going to save one tangent out with this secant, and then we're going to convert the rest to secant. So this equals 1331 times the integral of tangent squared theta, tangent theta, secant theta, d theta. Okay. Now, what is tangent theta? Or what is tangent squared theta? This equals 1331 times the integral of, well, secant squared. If you remember, secant squared theta is equal to tangent squared theta, and I do believe it's plus 1. But I'm checking that to make sure, but I'm pretty sure it is plus 1. It is. Okay, so therefore tangent squared, the other move it over here, is secant squared theta minus 1 is equal to tangent subtract 1 times the tangent theta times the secant theta d theta. And now look, we're set. So now what we do is we let u be secant theta. Why do we do this right now? Because du is secant theta tangent theta d theta, which covers all of this. So that's all in the du, and of course this is going to be u squared. So this is going to be u squared minus 1 with that 1331 out front. 1331 integral of u squared minus 1 du, which is, let me scroll down a little bit, equal to 1331 times u to the third over 3 minus u. Don't forget your simple power rules for integrals. Which is equal to 1331 times u. What is u? u is secant theta. Secant cubed theta over 3 minus secant theta, okay? But we want our problem to be in terms of x's, not thetas. Okay, so we need to know what secant theta is. Secant theta is actually both here. Well, secant theta is hypotenuse over opposite. We have it right here, actually. We have it right here. Secant theta is actually equal to this. So secant theta is the square root of x squared plus 121 over 11. So we'll just do that substitution. So this equals, let me back my marker, my pen here, 1331 times the square root of x squared plus 121 over 11 over 3, but this, of course, is cubed, minus secant theta is the square root of x squared plus 121 over 11. Okay? I'm going to put a plus c on this. This does need to be simplified. I guess we can kind of go through this. It looks like if we simplified this a little bit, let's try simplifying this. I do believe this 1331 and this 11 cubed is going to cancel, and at least for the first term. And then what is 1331 divided by 11? That's 121. So what we have here is I do believe the solution is x squared, square root of x squared plus 121 to the third. Okay, and of course you can write that, if you want to, as x squared plus 121 to the 3 halves. That's fine. This is over 3 minus 121 square roots of x squared plus 121 plus c. And there we have our solution.